GenAI and MLOps Part 34. This episode has 20 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario: A Vertex AI training job cannot access data in cloud storage. How do you debug it? Here's a strong way to approach it. Check the service account used by the training job, bucket IAM, object permissions, VPC service controls, CMEK permissions, region, and path correctness. Review cloud audit logs for denied permissions. If the job runs in a private network, also verify network and private Google access settings. Nice. Let's continue. Question 2. What is a feature store and why is it useful? Here's a strong way to approach it. A feature store centralizes feature definitions, storage, governance, and serving for ML models. It helps reduce duplicate feature logic and training serving skew. Good feature stores provide freshness tracking, lineage, ownership, offline access for training, and online low latency access for inference. Great. Moving on. Question 3. How would you design feature freshness monitoring? Here's a strong way to approach it. Track the expected update frequency for each feature, compare it with the latest observed timestamp, and alert when freshness violates the SLA. Add dashboards for feature owner, pipeline status, null rates, row counts, and distribution changes. Freshness monitoring is important because stale features can silently hurt model quality. Alright, next question. Question 4. Scenario: online predictions use stale features. How would you respond? Here's a strong way to approach it. First, confirm impact and identify which feature pipeline is stale. Mitigate by rolling back the model, switching to fallback features, disabling affected predictions, or using a previous feature snapshot if safe. Then fix the upstream pipeline, add freshness alerts, and improve dependency checks before serving. Let's keep going. Question 5. What are custom training jobs in Vertex AI? Here's a strong way to approach it. Custom training jobs let you run your own training code on managed Vertex AI infrastructure. You can choose machine types, accelerators, containers, Python packages, and distributed training configuration. They are useful when built-in AutoML or BigQuery ML is not flexible enough. On to the next one. Question 6. How do you package Python ML training code for Vertex AI? Here's a strong way to approach it. Put code in version control, define clear entry points, manage dependencies with requirements.txt or a container image, parameterize inputs and outputs, and write logs or metrics clearly. For repeatability, pin versions, store artifacts in cloud storage, and capture metadata in the pipeline or experiment tracker. Good. Here's another one. Question 7. Scenario: A Vertex AI training job fails only after running for 2 hours. What would you check? Here's a strong way to approach it. Check logs, memory usage, disk usage, data shard issues, timeout settings, package errors, quota limits, GPU errors, and whether a specific batch or file causes the failure. Add checkpoints so long-running training can resume. Also add smaller validation runs before launching expensive jobs. Nice. Let's continue. Question 8. How do you manage model versions in GCP? Here's a strong way to approach it. Use a model registry or structured artifact repository to store model version, training data reference, code version, parameters, metrics, approval status, and deployment history. Vertex AI Model Registry can help manage versions and deployment metadata. Strong governance makes rollback and audit easier. Great. Moving on. Question 9. Scenario: A newly deployed model performs worse than the previous version. What would you do? Here's a strong way to approach it. Rollback or shift traffic back to the previous model if user impact is significant. Compare offline metrics, online metrics, feature distributions, request segments, and business KPIs. Then review training data, evaluation logic, feature parity, and deployment configuration before trying another rollout. Alright, next question. Question 10. How would you implement Canary deployment for ML models? Here's a strong way to approach it. Deploy the new model to a small percentage of traffic and compare system metrics and business or model metrics against the current model. Monitor latency, errors, prediction distribution, conversion, accuracy proxies, and user impact. Increase traffic gradually only if predefined success criteria are met. Let's keep going. Question 11. What is batch prediction in Vertex AI? Here's a strong way to approach it. Batch prediction runs inference over large datasets asynchronously, usually reading input from BigQuery or cloud storage and writing outputs back to storage. It is useful when real-time latency is not required, such as daily scoring, churn prediction, recommendation refresh, or offline analytics. On to the next one. Question 12. Scenario: A batch prediction job misses its slaw. How would you troubleshoot? Here's a strong way to approach it. Check input size, machine type, parallelism, quota, region, model load time, output destination, BigQuery or cloud storage bottlenecks, and upstream data delays. Compare historical runtime trends. Fixes may include partitioning input, increasing resources, scheduling earlier, optimizing model code, or using a different serving pattern. Good. Here's another one. Question 13. How do you control cost for ML workloads on GCP? Here's a strong way to approach it. Right-size training and serving machines. Use autoscaling. Schedule jobs only when needed. Clean unused endpoints and disks. Monitor GPU or TPU utilization. Use labels, budgets, and alerts. And optimize BigQuery queries. For experiments, set quotas and life cycle policies. Cost control should not compromise reliability or model quality blindly. Nice. Let's continue. Question 14. Scenario: GPU training cost is too high. What would you investigate? Here's a strong way to approach it. Check GPU utilization, data input bottlenecks, batch size, training duration, checkpoint frequency, experiment duplication, machine type, region availability, and whether distributed training is efficient. Consider preemptible or spot resources for fault-tolerant jobs, mixed precision, smaller models, or better experiment governance. Great. Moving on. Question 15. What is AutoML in Vertex AI? Here's a strong way to approach it. AutoML in Vertex AI lets users train models with less custom code for supported use cases such as tabular, image, text, and video tasks. It is useful for fast baselines and teams without deep ML engineering capacity. Custom training is better when the team needs full control over architecture, code, dependencies, or optimization. Alright, next question. Question 16. How would you compare AutoML and custom training? Here's a strong way to approach it. AutoML is faster to start and operationally simpler, but offers less control. Custom training gives full control over model code, features, libraries, tuning, and advanced architectures, but requires more engineering ownership. The choice depends on business requirements, model complexity, team skills, compliance, and production needs. Let's keep going. Question 17. Scenario: A model endpoint must handle sensitive customer data. What architecture would you recommend? Here's a strong way to approach it. Use private networking where possible, least privilege service accounts, encryption, audit logs, restricted IAM, VPC service controls, private endpoints, and clear data retention policies. Avoid logging raw sensitive payloads. Add access reviews, compliance controls, and monitoring for unusual access patterns. On to the next one. Question 18. What is responsible AI in GCP ML systems? Here's a strong way to approach it. Responsible AI means designing ML systems with fairness, explainability, privacy, safety, transparency, and governance in mind. In production, this includes data quality checks, bias evaluation, model cards, approval workflows, audit trails, human review where needed, and monitoring for harmful outcomes. Good. Here's another one. Question 19. How would you include explainability in a Vertex AI workflow? Here's a strong way to approach it. Use explainability tools where supported. Capture feature importance or attribution outputs, and make explanations available to reviewers or downstream systems. Include explainability in model evaluation and approval. Explainability is especially important for regulated or high-impact decisions. Nice. Let's continue. Question 20. Scenario. A compliance team asks for ML model lineage. What evidence would you provide? Here's a strong way to approach it. Provide model version, code commit, training dataset version, feature definitions, pipeline run ID, parameters, metrics, approval record, deployment timestamp, endpoint version, and monitoring history. Also include IAM or audit logs and artifact locations. The goal is to prove how the model was created, approved, deployed, and monitored. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.